Hi, all right, welcome. I'm going to go over some of the solutions from the Chapter 2 review with you so that you can check your answers before the test on Thursday. This first video is going to be from page 50 to 51, number 73, 75, and 77. So looking at density, and scientific notation. So let's start with the density problem, number 73. Feel free as we go through these to flip through to the ones that you need help with. I'll try to write down all the numbers for you. So 73, it's asking you for the density. So you remember that density equals mass over volume. And in the question stem, they give you the mass. They tell you that the mass is 7.5 grams. So we can go ahead and write that into our equation. But we do need to figure out what our density is using the water displacement method. So in that case, they have two readings on the graduated cylinder. The first reading was 25.1 milliliters. And then when the object was placed in the graduated cylinder, the water level rose to 30.1 milliliters. So this change in volume is equal to the volume of the object. So we can just take the difference in that volume, and that's going to be 5 milliliters, and then plug that back into our equation over here. So 7.5 grams divided by 5 milliliters should give you 1.5 grams per milliliter for the density. All right, moving on to scientific notation. So we'll start with 75, question 75, and we've got A, B, C, and D. The good thing about scientific notation is it takes really, really small numbers or really, really big numbers and converts them into a form that's easier to use in math equations or to write in paper. So here we have a small number, 0.004583 millimeters, and we want to make that a number between 1 and 10. So scientific notation, you always take your number and it has to be between 1 and 10. And the way we do that is by moving the decimal point over. So I'm going to move the decimal point over to the right, 1, 2, 3 spaces, and that gives me 4.5834 millimeters. Now, since I moved it over, I guess I shouldn't have written millimeters there yet. Let me erase that. Okay. So since I moved the decimal place over to make this number bigger, I need to multiply it by the number of times. So I moved it over 3 times, so it's 10 to the negative 3 because that number is smaller than 0, so it's a negative number, and the unit was millimeters. So let's try that again with B. So B is another small number, 0.03054 grams. So I want to get that number between 1 and 10, so I move the decimal place over to the right, but this time only 2 spaces. So my number is now 3.054 and times 10 to the negative 2 grams because I moved it over 2 spaces. In essence, you divided it by 100. All right, and moving on to C. Let's go ahead and open another page here. C, now you're taking a bigger number and you're making it a small number. So you're going to move the decimal place over to the opposite direction. So if this number had a decimal, it'd be after the 1 place there, after the 4. So move that over 1, 2, 3, 4, 5 to get that number between 1 and 10. So now I have 4.38904 times 10 to the 5th seconds. So because that number was a bigger number, I'm going to have a positive exponent value there. And D, a really big number here. And that's in grams. And again, I'm going to move the decimal point. That would be after the 1s over 1, 2, 3, 4, 5, 6, 7, 8, 9. So in this answer, you only have to write the numbers that are significant. So you don't have to write these zeros that come after the 3 because they're not significant. we did move it over 9 spaces, so it'll be 7.0043 times 10 to the 9th grams. All right, so the next problem, number 77, is asking you to now add and subtract problems that are in scientific notation. So whenever you add or subtract in scientific notation, you have to make sure that your exponents, before you do any adding or subtracting, your exponents are the same. And so you may need to move the decimal point right or left in order to make that happen. So let's look at 77a to start out with. We have 6.23 times 10 to the 6th kiloliters plus 5.34 times 10 to the 6th kiloliters. All right, so if we look here, both of our exponents are 6, so we don't have to do anything, which is really nice. We just add our two numbers together. So 6.23 plus 5.34 is going to be a number that's greater than 10. It is 11.57, and we keep our exponents the same, 10 to the 6th. Is that in scientific notation, though? No, because this number, 11.57, is greater than 10. So we have to move the decimal point over one place, and we get 1.157 times 10 to the 7th now, kiloliters. So let's take a look at 77b and see if this is just as easy. So 3.1 times 10 to the 4th millimeters plus 4.87 times 10 to the 5th millimeters. So now our exponents here, 4 and 5, are not the same. So we need to change one of our numbers in order to get them the same. And I'm going to go ahead and move this decimal in the 3.1 over to the right to give me 0.31. And in doing so, I need to change my exponent here to 10 to the 5th because I made that big number smaller. So now when I add 0.31 plus 0.487, I can do that because those exponents are the same. And so my answer is going to be 4.87 plus 0.31, which is 5.18 times 10 to the 5th millimeters. All right, and 77c, last addition one, I've got 7.21 times 10 to the 3rd milligrams plus 43.8 times 10 to the 2nd milligrams. So again, look at the exponents. They are not the same. 43.8 is not in scientific notation, so I'm going to go ahead and make it in scientific notation, move that decimal over. So I have 4.38 now, and because I moved it to the left, making that big number smaller, I have to add my exponent here, 10 to the 3rd milligrams. So now my exponents are the same, so I can add 7.21 and 4.38, and in doing so I get a number again that's greater than 10, 11.59 times 10 to the 3rd milligrams. Now that's not in scientific notation, so I need to move my decimal point over, and I end up with 1.159 times 10 to the 4th milligrams. Make sure when you move the decimal over in your answer that you reflect that in your exponent. All right. I think that was it for number 77, or did we do subtractions? I think maybe we did subtractions, F, G, and H. So I'll go ahead and continue with those. All right, so 77 F, we got the same idea. We need to get the exponents the same. So we start with 3.57 times 10 to the 2nd milliliters minus 1.43 times 10 to the 2nd milliliters. Well, look at that. Okay, so the exponents are the same, so you don't have to worry about changing anything. You can just simply perform your subtraction. So 3.57 minus 1.43 would give you 2.14, and your exponents are the same, 10 to the second milliliters. All right, so 77G, we've got 9.87 times 10 to the fourth grams minus 6.2 times 10 to the third grams. All right, so here my exponents are different. So I'm going to change 6.2 to 0.62, and that will make it 0.62 times 10 to the fourth. That way, these are in agreement now. So I can perform my subtraction. So subtracting 0.62 from 9.87. And in that, you should get 9.25 times 10 to the fourth grams. All right, last one of these. And then I'm going to start a different video because it's kind of running long. 77H, we've got 7.52 times 10 to the fifth kilograms. And we're going to subtract 5.43 times 10 to the fifth kilograms. All right, so exponents are the same, both 10 to the fifth. So I don't have to change anything there, just perform my subtraction between my two numbers, and I get 7.52 minus 5.43. I get 2.09 times 10 to the fifth kilograms. All right, so that was problems number 73 through 77. I'll pick up with problem 78 on the next video.